Okay, so chapter 4 takes us away from polynomials for the moment. And what we are going to look at now are rational numbers, irrational numbers, and these fancy little things which you should recognize as, well, could be square root, or cube root, or fourth root, or so on and so on and so on. When we're looking at root signs, this number or thing on the inside of the root sign is called the radicand. And this value outside the root sign, which tells us what root to take, is called the index. And of course, this symbol is the radical symbol. And with chapter 4, we're going to play around with all kinds of different things and rules that all revolve around playing with radicals. Before we get there, though, just a quick look at how to estimate square roots and cube roots using knowledge that you should have a fairly good idea about, and use that knowledge of what we know of. In this case, if we're looking at square roots, our knowledge of perfect squares to estimate the square root of a number that isn't a perfect square. So here we just have a list of all those numbers in which we know are perfect squares. For example, let's skip all the way down here. 64 is a perfect square. Why is it a perfect square? Because 8 times 8 gives me 64. So that's where we get all these from. And you know all of these. You should know, well, you should know what 11 is, 121. You should know what 12 is, 144. You might have an idea of what 13 is, 14. 15 is a good one to remember. It comes up quite often, 225. But we can use this table of perfect squares to estimate the square root of values that aren't perfect squares. So here's our first example. Use the above table to estimate the square root of 30. So what we do is we look at our number, our value in this case is 30. Where does 30 fall in our number line? Well, 30 falls somewhere in here. I'm actually going to change colors to get rid of my blue. It matches the above too much. So we're looking for the number 30. 30 falls somewhere between 25 and 36. So I could say, well, I know what the square root of 25 is. Square root of 25 is 5. And I know what the square root of 36 is. Well, that's 6. The square root of 30 is going to fall somewhere in between there. Square root of 30 is going to be somewhere between 5 and 6. Well, 30 is pretty much right in the middle between 25 and 36. So I could approximate. I could say, well, you know what? The square root of 30, and I can't use an equal sign, is approximately, I use a squiggly equal sign. That's not a very good one, actually. Let's make this bigger, make it nice and neat. Square root of 30 is approximately 5. It's going to be bigger than 5. It's going to be smaller than 6. It's going to be kind of somewhere right in the middle, approximately 5.5. I could also use this symbol, an equal sign with a dot above. Both of those mean approximately. So remember, you're just estimating here, so you just have to come up with something that's a logical estimate of, and in this case, the square root of 30. I know that the square root of 25 is 5. I know that the square root of 36 is 6. Square root of 30 is going to fall somewhere in the middle. And in this case, it's going to be kind of right in the middle between 25 and 36. What's right in the middle between 5 and 6? Well, 5.5. And you could probably check this on your calculator fairly quickly. Second function, square root 30 is actually 5.4777. 5.477, which of course to one decimal place would round up to 5.5. Okay. So it is just an estimate, and this is one of those questions that on the provincial exam it would come up as one of those questions that you'd find on the no calculator section of your test, because you should have a fairly good idea of this information here, the perfect squares up to at least 12. It's something that you've been working on since since you started doing multiplication tables. And it's just some information that you should probably have a good idea about. So take a minute right now and estimate the square root of 8. And I'm going to come back. I'm going to quickly do that example and go into cube roots.